All right, you guys, we're going to continue our discussion of using the law of cosines. Okay, let's look at this problem. So it says directions. Solve triangle ABC if A equals 9.47 feet, B equals 15.9 feet, and C equals 21.1 feet. Okay, so the first thing I'm going to do, I'm going to draw a triangle. Okay, I'm going to label my triangle. Remember, uppercase letters go for angles, lowercase letters are for the sides. And I'm going to put in the triangle everything that I have. So A is 9.47, B is 15.9, and C is 21.1. All right, I'm going to make a chart so I can keep track of the things that I have and what I need. Okay, so now that I've filled in everything that I have, let's see if we can classify this triangle. So what we've been given are three sides. So this is a side, side, side triangle. Okay, so if you were asked to solve a side, side, side triangle, these are the steps you're going to follow. So the first thing you're going to do, you're going to use the law of cosines to find the largest angle. Step 2, you're going to use the law of sines to find either remaining angle. And then step 3, you're going to use the angle sum formula to find the remaining angle. Okay, so we're going to use the law of cosines to find the largest angle first. Okay, now remember, even without knowing what the angles are, you can tell which one is the largest because it will be across from the largest side. So if we're looking at our sides, our largest side is C, so that means angle C is going to have to be the largest. So we're going to find that first. So we're going to find angle C. And in order to find it, we're going to have to use the law of cosines. And I know that I'm going to have to use the law of cosines first because I don't have a matching pair. I don't have an angle and a side that's been given to me already. So I have to use the law of cosines. So for C, the law of cosines says C squared equals A squared plus B squared minus 2AB cosine of C. Okay, now for this, because I'm looking for the angle, I'm going to manipulate this formula so that it will give me the angle. Because right now, all of the quantity on the right side will give me side C. Okay, so I'm going to move some of my terms over. Okay, I have negative 2AB cosine C on the right-hand side, so I need cosine C by itself. So I'm going to divide both sides by negative 2AB. Okay, so that's going to change this into, I'm going to change the signs in the top. Just equals cosine C. All right, and I'm just going to move the negative term in the back. So A squared plus B squared minus C squared. Okay, so now that I have the correct formula, all right, I'm going to go ahead and plug in the values that I have into it. Okay, so I'm going to have 9.47 squared plus 15.9 squared minus 21.1 squared all over 2 times 9.47 times 15.9. And that's going to give me cosine of C. So when I plug that into the calculator, okay, I end up getting this number. Okay, so this is equal to negative 0.341094. And remember, we're looking for cosine C. We're actually looking for the angle, so I need to do the inverse. Okay, and when I do the inverse, I get my angle measurement. Okay, and remember, for these problems, we're going to stay in degrees. So C is equal to 109.9 degrees. Okay, so I'm going to put that into my chart. Okay, so we plug that in. Good. All right, now let's find angle B. So it doesn't matter, but let's just find B. All right, so now I can use the law of sines to find it because I have a combination. Okay, so I'm going to find angle B. And the combination that I have is for C. And because I'm looking for an angle, my angles are going to be in the numerator. So I'm going to have sine of C with a little c, sine B with a little b. And I'm going to fill in what I have. 21.1 sine of B with a little b, which is 15.9. And I'm going to cross multiply. Equals 21.1 sine B. And I need sine B by itself, so I'm going to divide by 21.1. So 15.9 times the sine of 109.9 degrees divided by 21.1 will give me sine B. So I'm going to plug that value into the calculator to get a decimal. When I do, I get this. 0.708558. And remember, I'm looking for angle B, so I need to take the inverse of this value. Okay, and when I do that, B gives me 45.1 degrees. Okay, so I can go ahead and fill that in on my chart. Okay, and the last thing I need to find is angle A. So since I already have the measurement for my other two angles, I can go ahead and just subtract that from 180. We can do that because we know that all three angles of a triangle have to sum to 180. So I'm going to say 180 minus 45.1 minus 109.9. When I plug that into the calculator, I get 25 degrees. And that's my third angle. Okay? And I know I'm finished because I have the measurements for all three angles and all three sides. Okay? Now, because this was a side triangle, okay, so I knew it was going to work, so I kind of skipped this step. But remember, you need to check the triangle length restriction law anytime you've been given a side triangle, which means when you sum any two sides, they need to be greater than the side that remains, okay? So if we're looking at our triangle, if I add side C and A together, is that greater than B? Well, let's see. C was 21.1. Plus 9.47. Is that greater than 15.9? Yes, it is. That worked. All right, if we add A plus B together, is that greater than C? Well, that would be 9.47 plus 15.9. Is that greater than 21.1? Yes. And the last combination we would have to have, we would say B plus C. Is that greater than A? Well, 15.9 plus 21.1, is that greater than 9.47? It is. So this would have passed, okay? But remember, anytime you've been given a side triangle, you need to check the triangle length restriction. Okay, had this triangle failed that initial part, we could have said no triangle before we did any of the work. So just make sure you always try that anytime you've been given a side triangle. Okay, awesome.